So in this question, we've been told that the lifetime of a certain brand of battery in tens of hours is modeled by the continuous random variable x with the probability density function shown below. So we have one function between 0 and 5 and a separate function between 5 and 10. We're asked firstly to sketch the function for all values of x. Well, the initial function between 0 and 5, I can see that that's a linear with a positive gradient. In the second interval from 5 to 10, once again it's linear. This is going to be a horizontal line. So visually I know what the sketch is going to look like. Let's just get that down. So the important markers, I'm just going to show the positive gradient, the increasing function, and then the horizontal line. Okay, so this is going to be the sketch. So let's substitute in the 5 and let's see what value we get for f of x. Well, we get a value of 2 over 15. So that is the height at the end of the first interval. And we can check that makes sense with the second interval, which has a height of 2 over 15 all the way through. Now, there are instances where these two numbers will not necessarily be the same, but when we do see them being the same through a calculation, that's often a good sign. Okay, next we're asked to determine the probability that x is greater than 4. So the probability that x is greater than 4 is actually going to be 1 minus the probability x is less than 4. Let's see that on the diagram. 4 would be here, and we basically have a triangle. The area here will be quite straightforward to find. We know the base, we don't know the height at the moment. To find that height, we'll substitute 4 into the function. So 8 over 75 is the height. The area of the blue triangle is going to be half times the base times the height. Half times 4 times 8 over 75. That is 16 over 75. And if we do a 1 minus, we're left with 59 over 75. That is the probability that x is greater than 4. Before part C, we're told that 2 batteries are needed for a piece of electronic equipment. This could be a remote control or a drone that's flying in the air. This equipment, whatever it is, this equipment will only operate if both batteries are still functional. If 2 new batteries are fitted to the equipment, determine the probability that this equipment will stop working within the next 40 hours. It will only continue to work if both the batteries are functional. So we just need to find the probability that both of the batteries are functioning after 40 hours. We could use a tree diagram to show this. The probability that they're both functioning is going to be 59 over 75 multiplied by 59 over 75. And as I said, the only way that it's going to stop working if this situation is not true. So 1 minus the probability of them both continuing to work. That's what we're looking for. And from there, we get 0.3816. 0.3816.